Hi, there are several use cases where you want to look at the metric in a burn down fashion. What does this mean? For instance, classical SLO, service level objectives, if you have an error budget and a burn rate, you may want to see a burn down. Or if you think about your Jira tickets, when you are working on tickets over a sprint, you want to understand how fast you're burning through that work, which means you're looking at all of the work that has been done, you cumulate it up, and then you kind of do a reverse, which means you start from your starting point at the beginning of the sprint, and then you see how fast you're burning down. So today what I want to show you is how you can really chart any type of metric in Dynatrace, also as a burn down, as you can see here, where in my example today, I start with a failure rate of a service. So let me get over to the big screen. Here we go. So what do I have here? This notebook is also linked in the YouTube video description. So really there's 3 steps. The first step is you want to find your metric. Could be failure rate, could be any type of burn rate, as I mentioned earlier, could be any work item size. Then we have a function in Dynatrace. In DevRel, it's called the arrayCumulativeSum. That's a tough word to pronounce for a non-native speaker, where you can accumulate up that metric over time. And then in order to get a burn down, instead of kind of like a ramp, you can use, or we can use the iCollectArray, which goes through all the data and then does a calculation. I just basically then say, we do a target, like where we start, and then we just do a minus of the value, and then we get exactly this burn down feature. So let me go down into this, scroll down here a little bit. So let's start with the first step. This is the metric itself. Now what I've done here, and let me just quickly edit so that you can see also the queries behind the scenes. I started with, example is failure rate. So I have a time series here that calculates the failures. So I do the sum of my failure count. I also get the total count. So that's the sum of all of my requests. And I'm looking at failure rate. So I'm just calculating the failure rate by using also the iCollectArray function to basically say, take all of the failures. So every element, every time series value of the failures, and divide it by every element in count. So that means I get a failure rate, right? The failures divided by the total number of requests is a classical rate metric. And if we look at this, I have charted now all of it. So I have count, I have failures, and then I also have the failure rate. And now if we want to make sure, we can just hide these. So here we have the failure rate metric. So the failure rate here is very low overall on my environment. It's great. But as I said, this is just a rate metric. So now the next thing is, how can we kind of accumulate this up? Second chart here, I want to introduce it. So it's the same base query, same 3 lines as before. But now I'm adding a fields add. I call it failure cumulative sum, where I use the array cumulative sum function and give it the failure rate. So what this function really does, it goes through every single value in the time series, and then it starts adding it up, and it generates a new time series where it takes the first failure rate, adds it up with the second, the third, the fourth, and the fifth, and so on. So that means this is exactly why we are then getting this beautiful kind of increasing line, kind of like what's the accumulated failure rate over time, right? And I also have here as a second metric just the failure rate itself and then the accumulated one. This is already useful, I would assume, for some of you that want to kind of see how things are accumulating over time. But now, how can we get the reverse? And so here what I have, same thing, I just copied the chart from earlier. So same thing, time series, failure count, failure rate. Then I have my failure cumulative sum as we had earlier. And now how do we get to the burn down? The burn down is really kind of like a reverse, right? If you think about an SLO, an error budget, you typically start with 100%. So your target would be 100, and then every time you're kind of like decreasing the value based on how much you burn down. Same would be with your sprint. If you have so many story points in your sprint and you have the individual story points that you consume, you can just basically reduce from the number of story points you have available in your sprint. And I do the same here. So I have a burn down failure rate, and I use the function again, iCollectArray, which is a really cool function. It basically again iterates through all of the elements in an array, but I can do some arithmetics, and I do here 1 minus. So my metric is a rate metric, so that means 1 would be 100%. So I start with 1 minus the failure rate, and very important here, the function takes an array. So this function really iterates over it, and it generates a new time series where it starts, the first value starts with 1, and then it just subtracts all of the following metrics, right? So, and with this, basically, I now get to a burn down chart, right? This is the one that goes down. I also charted the other one. Now, also a little bit of a tips and tricks. But one option would be obviously to then just hide the stuff that you don't want. Another tip and trick here, if you don't want a particular value, right? I basically end here with fields. I always add the time frame and the interval, and then the burn down rate, and then the failure cumulative, right? If I don't want that, I just remove it from here. That means that metric is not even in the final result. And here we go. Also, what I've done here with these, the background colors, the thresholds, if you click on visuals, right? This is where I chose the line chart. And if I scroll further down, I basically have here the, not the color here, sorry, the thresholds. Here we are with the thresholds. I just specified that everything above 0.8 is green, 0.6 and above, basically until 0.8 is yellow, and then the rest, everything above 0 is red. And this is how I get to these nice numbers, okay? And obviously now, because I changed my calculation earlier, let me just make sure the failure rate and the cumulative, I just make sure that this is all good. Perfect. Cool. Everything is good. Yeah, this is really I think the power of some of these DQL functions in that notebook. I also have the links to the documentation of the arrayCumulativeSum function, the iCollectArray, and what I also have, hopefully this excites you, I have another link to another dashboard that I've built. And this is the dashboard that kind of inspired all of this for me. It is how to apply this to SLOs and error budgets and burn down rates. So this is also available. I tried to explain a little bit about SLOs. I think I will do a separate video, but you can see here as well, I'm looking at the core metrics, the number of requests that are coming in, those that are failing, those that are successful. Then I calculate my rate metrics, my success and my failure rate. I then look at individual buckets. I do some cumulative calculation of the failure rate. And then I also calculate the burn rate, like how fast are we burning through our budget. And then here we go, I chart it, right? So hopefully this gives you enough ideas on what is possible. And yeah, with this, enjoy, let me go back. Enjoy putting your metrics on the burn down chart. Let me scroll back all the way down, right? This is, I think, exactly what you want. So you want to end up in a situation where you can take any type of metric, and if you need it, you can put it on a burn down using the iCumulativeSum function in combination with the iCollectArray. This makes it possible. Hopefully this was useful. Thank you. See you next time.